All right, so let's see. Then I get 2 to the negative 1 is
1 over 2.
2 to the 0 is
1.
good. 2 to the first power is
2.
2 squared is
4.
good. So negative powers make it small, which makes sense. 2 to a negative power would flip it, makes it 1 over something growing, it's getting smaller and smaller. If I put negative 18 billion in there, that'll be 2 to the negative 18 billion. It's 1 over 2 to the 18 billion. Somebody tell me anything about that number. 1 over 2 to the 18 billion. Is that a big number or a small number?
Really small.
Very small. 1 divided by stupid big is stupid small. But can I ever make the result 0? Can I raise 2 to a power and make it equal 0? No. This is something called Zeno's paradox. Have you guys ever heard of that? Sounds like a really good band name, but Zeno's paradox was presented to me like this. You guys ready? Zeno wants to go to the next town over. He's never going to make it. Because, I know it's bad for Gino. Because he's got to go halfway to the town first, and then he's got to go half of that distance, and then he has to go half of that distance, and then he has to go half of that. He's never going to make it there. You guys see that? If you just keep cutting in half the distance you are away from something, you never get there. Now, of course, you all have made it to the next town over before. You're like, something's wrong with Gino if you don't make it. He's like, now I got to go halfway. Now I got to go halfway. No, all right, Gino, stop it. And when I first heard it, I said, why don't you just tell Gino the next town is twice as far as it really is? Dumbass is going to go halfway. Just be there. Get over it. And my teacher's like, shit. But the real paradox should be you can't even start moving. Because you'd have to go half, and you have to go half of that, and you have to go half of that before you get started, and you can never even start moving. That's the real paradox. So what I'm trying to say is, every time you take a step back, look what happens. If I take a step back from 1, I cut it in half. I cut it in half. I cut that in half, so the next one back is 1/8. Cut that in half, the next one back is 1/16. I'm never going to make it to 0. So let's fill these in, and we're going to bring that back in. So negative 2 went to 1/4. So that's roughly half of a half. So right there. Negative 1 went to 1/2. 0 went to 1. 1 went to 2. 2 went to 4. So what happens over here is it just grows forever. What happens back here is it shrinks and shrinks and shrinks, but never quite makes it to the x-axis. What do you call that thing? It's a shirt I wore yesterday. I was one day off with that shirt. There's an asymptote here. It's asymptotic to the x-axis and never quite makes it there. That is what any exponential function looks like. If the base was 3, it would just grow faster. See, if the base was 3, what's 3 to the first power? 3. What's 3 squared? 9. So it just would grow faster. So if you ever watched a horror movie and they said something like either was a virus thing and like the virus is spreading exponentially, or the monster is growing exponentially. This is what they mean. I'm this big, now I'm this big, now I'm this big. You know, it's just growing like stupid fast. Or spreading stupid fast. In fact, the spread of a virus is exponential. It spreads exponentially. It goes, okay, oh shit. The whole world. Right? Zombies and Brad Pitt running around. What's Brad Pitt? Yeah. Just pick one and inject yourself with who knows what. All right. Sorry, if you've never seen that movie, maybe you can live without it. All right. So that is the look of any exponential. The base, what's always going to happen when you put a 0 in, no matter what that base is? Anything to the 0 power is 1. The base is never going to be 0, by the way, so that can't happen. Can somebody please tell me what would happen with this? Please.
You still plug it in?
No. I don't have to do any of this kind of shit work anymore. I've got that already right there. When I put a +1 with the x, what did this do? It moved square root of x where? Who remembers? No. Yes.
Left.
The opposite. It moved it back 1. What happened? Where's the vertex for this? Well, let's see, plus 3. Where's the vertex?
-1, 3.
-1, because it moves it back 1, up 3. That's why the vertex is -1, 3. So how's this going to move this? It's going to move it back 1. So I don't have to make a whole new table of values. I just take every point and go, you move there, you move there, you move there, you move there, you move there. And now I've got this thing. If I would have put a -1, it would have moved that way 1. If I would have put a +3 on the outside, it's going to take the whole thing and move it up 3. All that stuff we talked about before works for any function. In fact, it works even if it's not a function. If I replace x with x plus 1, it's going to take the whole thing, whatever the shit it looks like, and move it back 1. Right to the left 1. No matter what the function is, that's what it does. It kicks ass. That idea just always holds. All right. You guys like that one a lot. I'm trying to save you work. But if you don't want me to do that, I'll stop. It felt weird to me too. Looking at that purple line that we drew, what is the domain? Negative infinity to infinity. I can raise 2 to anything I want to. What's the range, though?
I have no idea.
Domain, yes, you do. Look at the picture. Domain is negative infinity to infinity.
Is
Negative infinity to infinity. Negative infinity to infinity?
What's the lowest output? Almost what? What's the lowest the output can be?
almost,
Almost,
but not quite.
almost, but not quite 0. That's why I put parenthesis on it. And then what's the highest output can be?
Infinity.
Infinite.
Yes, 0 to infinity. Just looking at the picture. Does it get any outputs below 1?
No. Yes.
Yeah, right there.
I'm not.
Does it get any outputs below that? Yeah. How about below that? Yeah. How about below 0? No.
No.
How about 0 itself? No. So then 0 to infinity, not including 0.
Okay.
Kick ass.
Oh, okay.
I like it. The only time it won't be this is if I shift it up or down.
What gives an arrow?
Say again? So if I do something like, if I did this, it would take that purple line, and take it down 1, down 1, down 1. Bless you. The asymptote would go down 1. That would go down 1, that would go down 1. So now it would look like this. What's the range now for this? What's the lowest output almost? -1. See, you can see the range right there. Whatever, the asymptote is at 0, so it's normally 0 to infinity. So if I make it move down 1, well now it's -1 to infinity. With the parenthesis on. This range would be -1 to infinity. Because I moved the whole damn thing down 1. So the floor for this dude normally starts at 0. That's where the floor is. And it never quite hits the floor. Right? If I move the floor down 1, then obviously that's the new floor. That's where, if I move the whole thing down 1, now it's 1 below. Yes?
But you can only move the line and like solve the g of x and h of x when you have already had your line, right?
Yes, if you have the base graph, I don't have to redo this shit. I can just move the points around. Because this says move it back 1, this says move it down 1. I can just take the points of the purple line and move them around. I don't have to recalculate all this shit, thank God. You could, you get the same answer. But why? You're smarter than that now. You're more sophisticated. That's my hope. All right. Now, let me come back to just 2 to the x. I'm going to make sure we can focus on just 2 to the x. I'm going to regraph it up here real quick. And then I want us to do the inverse graph. Right? All right, well, You haven't gotten there yet, so you're good. If you start snoring, I'm going to have to kick you. So what I want to do now, let me bring this back first. Yep, show up. Bow, 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 bow. Ooh. Okay. Make it big. All right, now, how would I graph the inverse function? What would the inverse function? We don't know what it is yet. In fact, we are going to give it a name. We are not going to get to choose, though, ha ha ha, because they already chose for us. And they made a poor choice. I almost made a single word out of it. They made a poise. It was a poor choice of symbol. It really, really was. We just have to get over that. Like any symbol, we just have to know what it's asking. We'll get to that in a minute. Let's first graph it before I even know what the shit it is. Why can I do that? Because I got the graph of this function. Why does this have an inverse? Why does it have an inverse?
A horizontal line test.
Because it passes the horizontal line test. So it's got to have an inverse. So tell me the points that the inverse would go through.
1/4, -2.
Yeah, 1/4, -2. 1/2, -1. 1, 0. 2, 1. 4, 2. Give myself some more points there. I like it. Okay. So here's the inverse. So you can do the inverse. What did I ask you to do this? Oh, yeah. Oh, yeah. I'm kind of skipping. Sorry. So in this sheet, you see the one with the little blue points on it? You guys all have this. You really do. Some of you guys are like, that's great. I have it. I don't care. I'm not going to look for it. Go ahead and graph the inverse on there. We've already got the points up here. Just graph the inverse on that graph. You've got the points right up here. I'll start to do it at the same time also. 1/4, -2. 1/2, -1. 1, 0. Do you see how that? Just plotting the points, right? Do you see how there's an asymptote here? If I flip it, where's that asymptote going to go? Here. If there's an asymptote on the x-axis, the inverse is going to have an asymptote on the y-axis. Why? Because this x's and y switch. That's it. So this one has an inverse. The inverse has an asymptote right here. Get out of there. Rah. It's not horrible for me. You can see the nice symmetry again. So whatever this function is, that's what it looks like. Oh, before I lose anybody else, dear God, let me give you guys the practice test. So everybody on your left is like, I don't need that shit. Just put this away for right now. Don't look at it in 3 now. Put it away. Stop freaking so loud. Jesus.
I don't remember logarithms ever really being hard. It was just like a lot you had to remember.
No. But I like the first thing you said. All right, now watch. You guys stay with it. There's an example of this type of thing that you're more familiar with, so it's not as freaky. What am I saying? So here's the function, right? We haven't designated a symbol for the inverse. If I have y equals x cubed, that has an inverse, right? What is it? What's the inverse of x cubed? What's the opposite of cubing something?
Cube
Cube rooting it. I like it. So, for example, this function is good if I want to cube something. If I want to cube 2, I put a 2 in. There you go. If I want the opposite, if I want to know 27 comes from what cubed, we could always write that if I want to say the cube root of 27, but that's stupid. It's a function. It should have its own symbol. I shouldn't have to relate it to something else happening. No, I should be able to do something to the 27 directly. And of course, the symbol we chose is the cube root symbol. So what's the cube root mean? It means what cubed is 27. That's what the symbol means, because that's where it comes from. You guys with me so far?
Yes.
So we know what roots are. We know how to think about them. We know the question they're asking. Okay, so the inverse function of this, so this works really well if I want to raise 2 to a power. So y equals 2 cubed, y equals 8. That's great. But the inverse has to accomplish this. If I have a 16, and I'm like, what would lead to this? What would I put in here to make a 16? That's the inverse's job, right? So this inverse is going to be, for example, in this case, it's what I raise to 2 to get 16. What's the power needed on 2 to make 16? Or how many 2's do I multiply to make 16? Obviously, here the answer is 4. I multiply 2 4 times, or I have to raise 2 to the 4th power. So the answer to this inverse function will be a power, because the original function's input is a power. So if the input of one thing is the output of the inverse, that's what they do. They switch the input and output. They switch the x and y. So whatever symbol I put down here, it's just capturing the question, how many of these things does it take to multiply to be this? So here's the unfortunate symbol they chose. It's from Greek, logarithmos, the study of numbers. And they're like, oh, that's amazing. They should have picked a better symbol, but too bad. They picked a symbol that is actually a word. All right. People see that? Just people see that, like, let me run away now. The flip, right? What the flapjack? But again, get over the fact that it's a word. And there's a lot of stupid-ass jokes out there. I'm not going to make any of them. Log cabin, whatever. When I write log base 2 of 8, what that is asking is, we have to internalize what the question is related to that. That means, if 2 is the base, what's the power to make the answer 8?
Okay.
Or how many 2's does it take to multiply, because that's what power means, to become 8?
Okay.
What's the answer? 2 to the what power is 8? 3. So the answer to a logarithm is always a power.
Okay.
The output of a log is a power because the input of the original function is a power.
So what's the meaning of a log?
Like I just said, it comes from logarithmos, meaning the study of numbers in Greek, and I think they thought they were being all whatever. They could have just made it. It would have been better to make the symbol a box with a 2 on it or something. And because think about it, really think about it. That is freaky shit. You're just used to it. To be honest, that's freaky shit. Why should that be the letter W? Because we picked it and we said it was. Right? You guys understand? So the only reason you know what this symbol means is because you're used to it. You're not used to this. If you haven't seen them before, especially. You just have to get used to it. But it could have been anything and we could have gotten used to it. This freaks people out because it's a word, but who gives a shit? It could have been a symbol instead, but oh well. Scheisse. So, some lightning round questions. And not lightning round yet, maybe. We just stepped into this. Let me see what you guys think about this. When I write this down, log base 7 of 49, what are you thinking to yourself? What's the question that's asking?
7 to the what power is 49?
7 to the what power is 49? Or how many 7's would you multiply together to make 49? They mean the same thing because exponents mean repeated multiplication, right? So, of course, what power would you need to put on 7 to make 49? Yeah. And just real quick, this is because 7 to the second power is 49. So I can always take a logarithm and rewrite it in exponential form. The same way I can do this. Cube root of 8 is 2 because 2 to the third power is 8. Right? I can always rewrite a root statement as an exponential statement. Can't I? I want you to notice something. And you're like, that's all I ever do. See how here the power is known is the third power. What's not known is what the base is. That's what roots are all about. If you think about it, what's the square root of 64? 8. So really, what do you square to make 64? 8. You guys with me? So here the power is known. The base is what you're figuring out. Here, the base is known. The power is what you're figuring out. That's the relationship. There's a really good, strong relationship between roots and logarithms. They're not the same thing, but they are related. All right, let's do another one. What's log base 3 of 27?
3.
Yeah, good. I always get somebody to tell me 9. And why would somebody say 9? What mistake did they make? 3 goes into 27. But why would I need a whole new symbol for 27 divided by 3? I think we got that covered. We got the division symbol. We got the bar. We're good on division. So that can't mean division. We're not like, let's make another symbol for division. No. This is an entirely different idea. Right? What does it take? How many 3's multiply by 27? 3. Or what power does 3 need on it to become 27? Third power. So your answer is always a power. I like it. What about this one? Here's one a little bit freakier. Just a tiny bit. Not too bad.
Oh. -1.
Yeah, what do you do to 7? What power do you apply to 7 to make it become 1/7? What makes things flip? -1, yeah. 7 to the -1 is 1/7. Logs are not bad as long as you force yourself to remember what the question is that's being asked. When you look at a square root symbol, you've already internalized the question. You've already internalized the translation of that. Math is foreign language, so here's a new terminology. What the shit's this mean? You got to stop and go, okay, what's the question? So like when I was learning French, you got to go, my name is, okay, je m'appelle, oh shit, okay. I couldn't just do it because it was a different language for me. I had to remind myself what the words were. You guys with me? You got to always remind yourself what the question is. All right, here's a really freaky one, just to warn you ahead of time. Yes, the answer will be fractional because you actually have to take a root of 8 to make it 2. Not the 4th root of 8.
1/8.
No.
I don't know.
Break 8 up into how many parts to make it 2, 2, 2? Well, obviously, you make it
1/3.
Yeah, so it's the 1/3 power. Because what root of 8 is 2? The cube root of 8 is 2. 8 to the 1/3 power is 2. Think about it this way. How many 2's make 8? 3. So then how many parts of 8 do I have to break up to make 2 again? 1/3. How about this one? This one's not nearly as freaky, but it could be.
Okay.
0. 1/8?
0.
Oh, 0.
Again, it's not multiplication, it's powers. What power do I raise anything to make it 1?
0.
0 power. 8 to the 0 is 1. So log base anything of 1 is 0 because that's the power you need on something to make it become 1. How are we doing? What time is it? It's not even 11 o'clock yet. Stop looking at me. At least the clock is here. Unfortunately, I feel like you're looking at it. It was back there, it always been like. can't be right. All right. Let me see some more. How about this? Log base 8 of 1/8. We already did one like that.
Oh, negative 1.
Negative 1. So I want you to notice something. I think we did this one earlier, but what's log base 8 of 64? 2. So if the number is bigger than that, it's going to be some number bigger than 1. I mean, you have to square 8 to make it 64. Right? If the number is smaller than that but bigger than 1, it's going to be a fraction. If it's 1, it's going to be 0. If it's less than 1, it's going to be a negative power because it's got to make it flip. Now, do you have to know all of what I just said? No. You can apply the idea every time, but that's an interesting observation to make. So, for example, what's log base 4 of 16?
2.
Yeah, because 4 squared is 16. That's all that means. Logs are nothing. Just thinking about, it's just all about, do you remember the question that it's asking? What's log base 4 of 4? 1. What's log base 4 of 1? 0. Right? What's log base 4? Let me put it in here. Log base 4 of 2. What do you do to 4 to make it become 2?
1/2.
1/2. If you got to cut it down, it's going to be a fractional power. It's going to be a root. Square root of 4 is 2, so that's 1/2. See how this is progressing? 16, 4, 2, 1. 2, 1, 1/2, 0. Now, what's log base 4 of 1/16?
1/4.
No. What is log base 4 of 16? 2. Then you have to do what to it? Flip it. What kind of power makes that happen? Negative. So it's negative 2.
Yeah.
So when it becomes less than 1, the answer's got to be negative because that's how I make it less than 1 is to flip it. It becomes fractional then. So just to make a big point of what I just said, what's log base 3 of 9? 2, because 3 squared is 9. What's log base 3 of 1/9? Negative 2. 2 to make it 9, negative to make it flip. How many of you guys have never seen logs before today? A few of you guys. Okay. Some of you guys have seen them before. I won't lie. Didn't like them. I still don't like them. Make a house out of them and just screw it. It's like, all right. Can you rewrite this in exponential form? What does this mean? If this is a true statement, this must mean that
B to the X.
b to the m equals
A.
b to the m equals a. The answer to a log is always a power. The power that the base needs to make the inside. So how do I read this? Log base 3 of 9 is 2. Log base b of a is m. So the base is b, the power is m, and the answer is a. That's how I can always rewrite between the two. And look at this. What's the output to the log up here? What's the output to the log? M. And what's the input over here? M. The output and the input switch. Alright, so just so that fewer of you jump me on the way to the car and try to kill me, I think we'll stop there. So I see murderous intent in some of your faces. What's going to happen tomorrow is we're going to start off, we are going to definitely do, we made it up to 12.3.
Really?
We're going to do 12.4 tomorrow, and then the rest of tomorrow is review. And the rest of 12 will be on the next, will be on the final. So we're going to finish up 12 and look at some of the other sections. I'll give you, the homework. I guess everybody else who left is like, I never do that shit anyway, who cares? Yeah, I said that about you. Oops. Let's do this. So 12-1. Make it up right now, Jeff. Yeah, okay, I like it. Let's do, oh, yeah, that's what I mean. 10 through,
This is for 12-1.
yeah. 40, 45. 10 through 40, every fifth one. And then 42, let's do 42 through 63, every third one. And then, let's see. Ah, here we go. Let's do 75 and 83 and 84. There we go. Wow. Probably should write that.
I was about to say you recorded, so at least you'll
I
always
know.
have it.
I know I'm lazy enough to not want to try to fast forward to this point. Let's see. All right, cool.
So, we're probably going to see this tomorrow. What's INS?
INS.
INS?
Sounds like Immigration and Naturalization Service.
Are you calling me an immigrant? What's that IN?
LN.
LN.
LN. It's that's a special law. That's called a natural law. It's referring to a special base.
Is that better than...
No. It's just more widely used. It's like the equivalent of a square root being the most used thing.
Yes.
That's why the 2 doesn't show up. So you got, yeah. So we'll talk about it.